See, in today's class, we are going to discuss about estivation. What is estivation? Estivation is the arrangement of sepals or petals in the bud condition. So the arrangement of sepals or petals in the bud condition, we call it as estivation. So the types of estivation are valvate estivation, twisted estivation, imbricate estivation, vexillary estivation. So vexillary estivation. So these are the four types of it. There is also one more quinquential estivation, which they have not included here. So the types of estivation are, there are four types of estivation: valvate estivation, twisted estivation, imbricate estivation, vexillary estivation. See, if you take the section of the bud, and if sepals or petals, they exhibit this condition. So wherein you know that the valvate estivation, the in this particular diagram, the petals, they are neither overlapping nor overlapped. All the edges of the petals are free. They are neither overlapping nor overlapped. So we call it as neither in nor out. Okay, simple term. So but in your books, they would be using the term the petals or the sepals, they are neither overlapping nor overlapped. When you take a thin section of it and observe here, see in this diagram valvate estivation, you can notice that all the petals are free. They are neither overlapping nor overlapped. So the edges of the petals are neither overlapping nor overlapped. So this type of estivation, we call it as valvate estivation. See, this can be seen in sepals or petals. Okay, so estivation is the arrangement of sepals or petals in the bud condition. We call it as estivation. Now, in case of hibiscus flower, when you take the bud of hibiscus flower, so you can notice that a part of the petal is overlapping, a part is overlapped. So in simple terms, a part is out and a part of the petal is in. So a part of the petal is overlapping, a part of the edge of the petal is overlapped. So two edges are there in a petal. One edge is overlapping, the other edge is overlapped. That is, one is out, one is in. So in and out condition. So they have five petals, all of them exhibit this. So they have in and out, in and out, in and out conditions. So where a part of the petal is overlapped and another part of the petal is the same petal, it is overlapping, overlapped and overlapping. So this in and out condition you can notice in all the five petals. So they give the appearance of a twisted appearance. That is why this estivation is called as twisted estivation or contorted estivation, we call it as. In case of twisted estivation, what you can notice is one part of the petal is overlapping and the another part of the petal is overlapped by another petal. So this sort of condition you can see in all the petals, there is one part is overlapping, the other part is overlapped. So all the petals exhibit this in and out conditions. So we call this type of estivation as twisted or contorted estivation. We can notice this twisted or contorted estivation in the buds of hibiscus. When you look into the petals, petals exhibit this twisted estivation. You just see even the bloomed flower, the edges, the base of the flowers, they'll be showing this. One part is overlapping, one part is overlapped. Now in imbricate estivation, so this type of estivation you can either see in sepals or petals. What you notice is in the above diagram, you can see one part of the petal is completely inside. So one part of the petal is completely inside, and at this end, one part of the petal is completely outside. That that is, one petal is completely overlapped, another petal is completely overlapping. The remaining three petals, what you can see is a part of it is overlapping, the other part is overlapped. So a edge of one of the petal is overlapping, another part is overlapped. So you find in simple terms, if I put it as, so out of five petals, one petal is completely in, one petal is completely out. See, you can see one petal is completely in, one petal is completely out. The remaining three petals are in and out condition. You can notice in imbricate estivation. So in imbricate estivation, the first petal is completely in, uh, then one petal is completely out. The remaining three petals are in and out condition. You can notice in case of the imbricate estivation. So that this sort of arrangement where the first petal is completely in, we call it as imbricate estivation. Vexillary estivation is also a type of imbricate estivation, but here the first petal will be completely out. And you can notice this vexillary estivation in Papilionaceous corolla. So the vexillary estivation is noticed in Papilionaceous corolla or the Fabaceae family. You can notice. What is the thing that you notice here is the first petal is completely overlapping. Okay. Then the lower petal is completely overlapped. Remaining petals partially overlap, partially overlapping. So this you can notice. In simple terms, I'm saying it as in vexillary estivation. One of the first petal is completely out. The other petal is completely in. The remaining petals are in and out condition. So vexillary estivation, you can notice that in case of Papilionaceous corolla. So these are the types of estivation. So there are estivation is the arrangement of sepal or petal in the floral bud condition. We call it as estivation. So the types of estivation are valvate estivation. In valvate estivation, all the petals are free. All the sepals or petals are free. In twisted estivation, the sepals or petals, one part of the petal is in, one part of the petal is out. So one part is overlapping, one part is overlapped. So all the petals show this partially overlapping and partially overlapped. So they appear like a twisted condition or a contorted condition. That is why this estivation is called as twisted or contorted estivation. So this twisted estivation you can notice in the buds, bud condition of the hibiscus or China rose or daswala. So you just notice in the bud condition, the petals exhibit this in and out, in and out, in and out condition. So in imbricate estivation, one petal is completely overlapped, another petal is completely overlapping. See, the first petal in imbricate estivation is completely overlapped. The other petal is completely overlapping. Remaining three are partially overlapping, partially overlapped. So one petal in, one petal completely out, remaining three in and out condition. That we call it as imbricate estivation. So vexillary estivation is similar to imbricate. Only thing here is the first petal is completely out. So that is completely overlapping. So you can notice this in Papilionaceous corolla. The first petal is nothing but the standard petal. Standard is also called as vexillary. So the name vexillary estivation is derived from that. The first petal is completely overlapping. Another petal is completely overlapped. That is the keel or carina is completely overlapped and they are fused also. The remaining petals, what you can notice is partially overlapped, partially overlapping. So one in, one completely out, one in, remaining petals in and out. We call it as vexillary estivation. This we notice in case of the Papilionaceous corolla. So again, in detail, with examples, we can notice I was talking about the echidna. You might now recollect seeing this flower and plant, isn't it? So they have milky latex. This is Calotropis or echidna. So the sepals or petals in the whorl just touch one another at the margin without overlapping. So they just touch at the margin, but they are not overlapping. This you can notice. See the petals of this, they just touch at the uh, margins, but they are not overlapping. So this type of arrangement of petals without overlapping, we call it as valvate estivation. It might, this valvate estivation can be seen either in the sepals or in petals. The example is Calotropis. Calotropis is nothing but echidna. So they have this milky latex. So now you are very much in a position to easily identify this Calotropis, isn't it? So sepals or petals are just touching each other, but they are not overlapping. Example is Calotropis. That is valvate estivation. In twisted estivation, one margin of the appendage overlaps, and the other margin of this appendage is overlapped. Okay, one margin of the appendage overlaps of that of the next one, and so on. So the other margin of the same petal will be overlapped. One margin is overlapping, another is overlapped. So this gives the appearance of twisted appearance. All the five petals here are in and out condition, that is overlapping and overlapped. So this gives the appearance of twisted appearance, and you can notice this in hibiscus. So you can see that one edge of it is overlapping, the other is overlapped, overlapping, overlapped. So as a result of this, this gives a twisted appearance. And if you look into the bud condition, you can notice this twisted appearance in a much more better way. Example is China rose, that is hibiscus rosa sinensis, lady's finger, and cotton plant. The flowers of these, they exhibit the twisted estivation. In imbricate estivation, the margins of sepals or petals, they overlap one another, but not in a particular direction. That is, you find one petal is completely overlapped. First petal is completely overlapped. Then one petal is completely overlapping. Remaining petals are partially overlapping and partially overlapped. So remaining three petals are partially overlapping and partially overlapped. In simple language, you can say it as one petal is completely in, the first petal is completely in, another petal is completely out. Remaining three petals are exhibiting in and out condition. So this type of estivation, where the first petal is completely in, we call it as imbricate estivation. Now you can notice this in cassia and gulmohar. See, cassia plant, this is how the flowers are hanging. They are very beautiful to look at. Even if you go on the nice road, you find many places this cassia plant would be flowering. So this is seen locally. This is the flower of cassia. And in cassia, the first petal, if you notice here, it is completely over inside. That is completely overlapped. Okay. So this condition you can notice in case of the cassia plant, the imbricate estivation, where the first petal is completely overlapped. The remaining one petal is completely overlapping. The remaining three are partially overlapped, partially overlapping. So we can use simple terms like one petal is completely inside, one petal is completely outside. Remaining three are in and out condition, you can notice. So even in Gulmohar, this Katika Imara, I told you about, where you have this uh, imbricate estivation. Next is the vexillary or papillonaceous estivation. Vexillary estivation, here there are five petals. The largest standard, so this is the largest petal. The standard overlaps the two lateral petals or wings, which in turn overlaps the uh, two smallest anterior petals or keel. So the keel is completely overlapped. The standard is completely overlapping. Even here you notice one is completely out, one is completely in, the remaining are in and out condition. So this type of vexillary estivation you notice in case of pea plant and beans. So all the pulses they exhibit this. All the plants which have papillonaceous corolla, they exhibit this vexillary estivation where the first petal is completely overlapping. That is, it is completely out. So you can notice here the standard petal which is completely overlapping. This is also a standard petal which is large and completely overlapping. Then you find two pairs of petals which we call it as wings. The keel or carina are the boat shaped structure that are fused. So remember about this papillonaceous estivation or vexillary estivation. Example is pea and bean. So there are five petals. The largest standard overlaps the two lateral petals, which in turn overlaps the two smallest anterior petals, that is the keel, which is fused to form the boat shaped structure. Okay. So example is pea and bean are example for vexillary estivation. I was telling you about the quinquential estivation. This quinquential estivation is noticed in the sepals of uh, the sweet potato, sea gensum. the sepals of sweet potato plant, you can notice this quinquential estivation. What is there unique is two petals are completely in, two petals are completely out, only one is in and out. Out of five petals, two petals are completely inside, that is overlapped. Two petals are completely outside, that is overlapping, and only one petal will be partially overlapping, partially overlapped. So this condition we call it as quinquential estivation. So if any plant exhibits quinquential estivation in its sepals, you can immediately identify it to be a plant belonging to sweet potato family. So that is what you have to remember about. So they are a plant belonging to sweet potato family. In quinquential estivation, two petals are completely out or overlapping. So two petals are completely in or overlapped. One petal is partially overlapping, partially overlapped. So this condition is noticed in the sepals of sweet potato family. So the we call it as convolvulaceae family. Anyway, sweet potato you can remember. So if any of the plant sepals they show this quinquential estivation, where you can place them under the family convolvulaceae or sweet potato family. So remember about that. They've not included it for your uh, NCRT book, but you should know about this quinquential estivation. Now we'll go for the discussion of the third whorl of a flower, androecium. Androecium, you know, is the male reproductive part of the flower. So what is androecium? So it's a collection of stamens. So each stamen represents the male reproductive organ. What is the stamen made up of? It consists of a stalk, which we call it as the filament, and it consists of lobes, two lobes, which we call it as anther. In some of the plants, they have only one lobe. Here you find two lobes. So this is the anther. So it consists of a stalk structure called as filament and a lobed structure called as anther. Okay. So in this particular diagram, you can notice that they have this nectar region, the ovary, everything is in detail they have given. So you can see the stamens. Okay. Within this anther lobes, they have this pollen grains. Okay, anther is called as microsporangium, and the pollen grain is called as microspores. So you'll be studying about those details in the second year PU when we come to the discussion of sexual reproduction in flowering plants. Now, as of we are just describing the morphology, know that androecium is the male reproductive part of the flower. It is an essential whorl. Then androecium is a collection of stamens. Each stamen has a stalk, which we call it as filament, and an anther is there. Anther is also called as microsporangium. Within this anther, you find the pollen grains. Okay, so that is what you have to remember about. So each anther is usually bilobed. They have two lobes. So we also call this anther as dithecous because they have two cavities or two lobes. So we call this as bilobe. Each lobe has two chambers called as pollen sac. See each lobe when you dissect it, you can see that they have two lobes called as pollen sac. So we call it as sporangium. So tetrasporangiate, when you take a section of dithecous anther or bilobed anther, you can find four sporangiums. So we also call it as tetrasporangiate condition. See, they have two pollen sac or two sporangiate structures. Okay, the pollen sacs contain pollen grains. The pollen sacs contain the pollen grain. A sterile stamen is called as staminode. So you should remember a sterile stamen is called as staminode. So male flower is called as staminate. NATE, male flower, unisexual flowers, male flower, we call it as staminate. A sterile stamen, we call it as staminode. So remember about this aspect of it. So the anther has two lobes. We call it as bilobed anther or dithecous anther. Each lobe has, within this lobe, each lobe has two chambers called as pollen sacs, and the pollen sac contains the pollen grains. A sterile stamen is called as staminode. So this is what initial level of androecium details you should remember. Then there is one more terms for 1 mark questions they might be asking you. When stamens are attached to petals, they are called as epipetalous. Example, brinjal. So brinjal flower you can notice here. When stamens are attached to the petals, we call it as epipetalous. When stamens are attached to perianth, like in lily flowers, if they are attached to perianth, they are called as epiphyllous. Example, lily flowers. So both of them they have given here. So even in case of the uh, jasmine flower, I told you stamens are attached to the corolla tube, or in Kankambra. Even there, if you dissect that tube-like structure, you can notice two stamens would be present in jasmine flower. Even in Kankambra, you can notice the stamens attached to that. So that is called as epipetalous condition. If stamens are attached to perianth, see what is perianth? If we cannot differentiate between calyx and corolla, we call it as perianth. As in case of lily flower, if they are attached to the perianth, we call it as epiphyllous. Example is lily flower. If the stamens in a flower are free, okay, just like we had the sepals free, we call it as polysepalous. If the stamens in a flower are free, it is not fused, we call it as polyandrous. If the stamens are united, we call it as synandrous. So if the stamens are united, it is called as synandrous. Especially in pumpkin flowers, they are completely fused. The synandrous flowers you can notice. Okay, if the stamens in a flower are free, it is called as polyandrous. If the stamens are united, it is called synandrous. See here, polyandrous flower, they are showing the free stamens in case of lotus. All of them are free, none of them are fused, and they are infinite number. Their number is not countable, more than 10. Whenever the stamens are there, we just call it as infinite numbers. Even in the synandrous flowers, you can notice in the China rose or hibiscus, what you can notice is they have a numerous uh, anthers. So all of them are fused at their filament level to form a stalk. This stalk is called a staminal tube. And when you dissect the staminal tube, within that you have the style. So they have formed a single bundle. See, in this case, they have formed a single bundle, and we call this as staminal tube. Okay, so this sort of where stamens are fused, we call it as the synandrous flower. Monoadelphous especially we call here. So adelphous means in a androecium, adelphous implies if only the filaments are fused and anthers are free, we call it as adelphous. And in case of China rose, the hibiscus, you can see only one bundle formed by the fusion of the filaments. That's staminal tube. So we call this as monoadelphous. In case of hibiscus, we call that as monoadelphous. So we'll see in this next slide. See, they are of many types. The fused stamens are of many types. Monoadelphous, they form a single bundle. See, all these stamens at the filament level, base of the filament, they are all fused to form a tube-like structure. We call it a staminal uh, tube. Okay, and since they are a single bundle, they have all fused to form a single bundle. We call it as monoadelphous. And when you dissect this terminal tube, you can see inside them the single style, slender style, which gives rise to this pentaphyte stigma. So these are the stigma. The style is inside the terminal tube, and they continue. Some of the students who had dissected the flower and sent me those images also of hibiscus. Good. So diadelphous, you can notice it in case of this Fabaceae family. All this, if you have the Shankha Pushpa, you can dissect it and see. Or if you have this, uh, the pea plant, Botanigida, the flowers, they have this diadelphous stamen. I told you keel or carina. This keel or carina will be having this diadelphous stamens. So diadelphous stamens, they are having two in bundles, and they are fused only at the filament region. not at the anther region. So they are fused only at the filament region and they are having two bundles. So especially in case of this Fabaceae family, we call this arrangement as 9 plus 1. We put 9 within brackets plus 1 outside. Can you see one stamen is completely free? That is one bundle. The remaining what you see here is 9 of the stamens. They are fused at the filament and they form a single bundle. So 1 plus 1 bundle. 9 are fused at the filament level. So you put that 9 within brackets plus one stamen is there. So there is two bundles. In first bundle, they have 9 stamens and in the second bundle they have only one free stamen. So this type of two bundles are found in case of pea plant, Papilionaceous corolla. All of them will be exhibiting this diadelphous stamens. You just have to dissect the flower and see them. Okay, so they have 9 plus 1 arrangement where 9 stamens are fused at their filament part of it and one stamen is completely free. So the 9 stamens we put it within brackets, one stamen plus 1 we add it separately. So since they have two bundles, one bundle has 9 stamens fused, another bundle is a single stamen. We call it as diadelphous stamens. Okay. So then in case of polyadelphous, you can see this in citrus flowers. The flowers of citrus plants, you can notice this polyadelphous condition. Poly means many. So there would be many bundles in this citrus flowers, more than two bundles. If any flower is exhibiting, we call it as polyadelphous type of stamens. So that is noticed in case of citrus flowers. So you can notice here, they'll be having more than one bundle where they are fused at the filament region. See, whenever we use the term adelphous, it implies only the filaments are fused and the anthers are free. Okay, this we call it as adelphous. So in some of the flowers, there might be variation in the length of filaments of the stamen within a flower. So in some of the flowers, there may be variation in the length of filaments within a flower. Okay, so salvia, I was talking about Tumbegida bilabiate corolla. So this is seen in the parks. Red variety you might have seen. ಸೊ ರೆಡ್ ತುಂಬೆ ಅಂತ ಕರಿತೀವಿ ಕನ್ನಡದಲ್ಲಿ. ಸೊ ದಿ ರೆಡ್ ವೆರೈಟಿ ದೇ ಗ್ರೋ ದಿಸ್ ಆಸ್ ಅನ್ ಆರ್ನಮೆಂಟಲ್ ಪ್ಲಾಂಟ್. ದೇ ಹ್ಯಾವ್ ಟೂ ಲಿಪ್ಸ್, ದಿ ಅಪ್ಪರ್ ಲಿಪ್ ಅಂಡ್ ಲೋವರ್ ಲಿಪ್. ಯು ಕ್ಯಾನ್ ನೋಟಿಸ್ ಇನ್ ಕೇಸ್ ಆಫ್ salvia. See the salvia, the variation in the length of filaments is noticed within a flower. So in salvia, you notice that they have two lobes, a sterile lobe and a fertile lobe. So you can also notice this lever mechanism of uh, in case of the salvia, you notice this lever mechanism. The length of the filaments will be different. In case of mustard plant, they have 6 stamens, out of which 4 stamens are long. The length of the filament is long, and 2 stamens have a short filament. So variation in the length of filaments within a flower. A very good example is mustard plant. So you can see 4 stamens are long, 2 stamens are short. So 4 long, 2 short. Okay, 4 stamens are long and 2 stamens are short. So in case of this, you notice salvia lever mechanism. You notice that I don't want to go into detail because that itself takes more time. So maybe in a simple video I might share later the lever mechanism. See, lever mechanism is a condition where the two lobes of the anther are extended. So that the one lobe, the fertile lobe is inside, the sterile lobe is outside. So when the insect enters through this mouth of this corolla, bilabiate corolla, they push the sterile lobe. And when they are, see, the fertile lobe is here. So when they enter inside, they have the sterile lobe which they push. So the abdomen of this insect will be dusted with this pollen grains of fertile lobe. This is the fertile lobe. Inside will be the sterile lobe. So when they go inside, it is like a seesaw mechanism. When they go inside, the sterile lobe they are going to touch because the insect goes inside the flower to collect the nectar. During this process, The fertile lobe, when the sterile lobe is pushed inside the fertile lobe, it dusts the pollen grain on the insect. So we call this as uh, the lever mechanism in salvia. There are some flowers, even in case of this pichkari mara I was talking about. When you get that flower, you just dissect the flower and see. Two stamens will be long. They are curved inside. Two stamens will be long because the filaments are long, and two of the stamens will be short. So we call that as didynamous condition. If two stamens are long and two stamens are short, we call it as didynamous condition. If four stamens are long and two stamens are short, we call it as tetradynamous condition. So maybe for NEET it might be required, but not for your NCRT part. So if four stamens are long and two stamens are short, we call it as tetradynamous condition. If two stamens are long and two stamens are short, we call it as didynamous condition. So these things you should be knowing about the different uh, stamens where they differ based on the length of filaments within a flower. Salvia exhibits lever mechanism wherein they have two lobes separated by a long stalk, the sterile lobe and the fertile lobe. So when the insect enters inside and pushes the sterile lobe, so the fertile lobe does the pollen grain on the insect. So the abdomen of insects, that is how it brings about its pollination. In mustard, they are having four stamens are long, two of them are short. So you can notice in this flower itself, four of them are long and there are small short ones. So we call this as tetradynamis. In a few flowers, like in case of this Pichkari mara or the Spathodia campanulata, you notice that the stamens, two of them will be long curved and two of the stamens will be short. The filaments are short there. So the long stamens will have a long filament. So we call that as didynamous condition. Too long, too short. Here in case of mustard, four long, two short stamens you can notice. Okay. So this is what you can remember. In case of the sunflower, disc florets of sunflower, you notice that only the anthers will be fused. The filaments are free. What do we call that condition as? We call that as syngenesious condition. In case of the disc florets of sunflower, the anthers are all fused, stamens are free, the filaments are free. Anthers are all fused and filaments are free. We call that condition as syngenesious. In case of the cucumber or the pumpkin flower, you notice that both the the stamen, the complete stamen is fused, that is the anther as well as filament. We call that condition as synandrous. See this definitions, you should be very clear in your NCRT book. They are not clear. When you go through this reference books, you'll come across that. See, adelphus means only the filaments are fused, anthers are free. Syngenesious means only the anther lobes are fused, filaments are free. If both anthers and filaments are fused together, as in case of pumpkin flower, male flower of pumpkin, we call that condition as synandrous. So there are three terms: adelphous, only the filaments are fused; syngenesious, only the anther lobes are fused, as in case of disc florets of sunflower; synandrous, entire andrecium is fused, that is, both filaments and anthers are fused. We notice that condition in case of the uh, pumpkin flower. So we call that as synandrous condition. So remember these terms. Later, when I'm going to send you the uh, list of regular classroom recorded videos, so you can watch this where I've given a detailed description of andrecium and gynecium. More terminologies have been explained than your syllabus part. Okay, so in today's class, we have completed up to andrecium. So in the next class, we'll discuss about gynecium. Do you have any doubts or clarification, students?
Sir,
Yeah, 1 minute.